And yeah, thanks everyone for joining. This is meant to be interactive, so if you want to try to follow along, you can. We will move kind of fast, so if nothing else, you can always refer to the recording after the fact, and I'll also share the Git repo that we build along the way. Let me share my screen here, and we'll do a quick introduction, but then we'll spend most of the time actually just building something together. So that way we can try to build and deploy an agent, together. So a few just kind of introductory slides. So our first things first, what's the goal? Let's try to build and deploy our first AI agent. Some of you might have already built some things, some of you have not. And so we'll start from the beginning, talk about kind of the whole process, and then we'll show a little bit of how you do it in Mastra. And of course, talk about and maybe have some time for some questions at the end. So we're going to learn some common AI engineering concepts, and we're going to learn some of the Mastra kind of core primitives, agents, workflows, evals. Who am I? I'm a founder and chief product officer of Mastra. I was in engineering and product at Gatsby and Netlify before. I built audio feed, and I've been, this dates me a little bit, but I've been in open source software for over 15 years now, starting, when I first started a website development company about 15 years ago, working primarily with Drupal. So I've been doing a lot of open source stuff over the years, and some info to connect with me if you have not already. But the first thing that I think is worth answering or talking about is, what are agents? There's a lot of debate on what's considered an agent. I think the easiest definition I've seen is just it's some kind of software with non-deterministic code, meaning you can't always predict the result. There's something making a decision that's not our traditional, deterministic code that we write where we know if it gets executed, it's going to return the same thing every time. But it's really a spectrum. It's something that's maybe considered less agentic is something that is mostly deterministic, but maybe there's a call to some kind of AI system, typically an LLM, but wouldn't have to be. Something that's a little bit more agentic would be if you're using LLMs to kind of build and execute their own plans and access their own tools. And so they're making more decisions. And therefore, since the LLM's making more decisions, it's a little bit more agentic. And then kind of like the most agentic, the examples that we have would be something that's more fully autonomous that runs with very little or no human input. An example there might be like a self-driving car. So you got all the way from like a simple trip planner to maybe a customer service assistant, all the way to full self-driving. And there's also been a lot of talk around, do you need a framework for this stuff? And I think it's like anything else. No, you of course don't, but I do like this tweet here, if you, I'll let you all kind of read it, but you start to, as you get into this stuff, realize that there's a ton of new concepts. Ultimately, it does follow a lot of the uh, software development best practices. So if you've been building software before, you're going to see that a lot of it's pretty similar. But there's a lot of new concepts that make a lot of this stuff, working together kind of confusing. And that's where we really see the opportunity for frameworks like Mastra to come in. So Mastra is an open source AI agent framework for TypeScript. And what's included with Mastra, we have agents that have tools, memory, tracing. We have state machine based workflows. So that you can do human in the loop, meaning you can wait for the human to respond and then continue a workflow. We have evals, which we will get to show today. And then we have storage for RAG pipelines, a local development playground, and a whole bunch more that's not included. But our kind of high level principles is we want to provide something that's opinionated. So you don't have to make a lot of decisions to try something out, but it's flexible, that you can piece together and you're not kind of locked in. So an example of that would be, by default, you get, storage baked into Mastra, and you get kind of a vector database baked into Mastra, but you might want to use Pinecone or PG Vector, and so you can just swap that out. And if we don't have a supported provider, you can write one yourself. So we do want to be opinionated, but allow you the flexibility to really piece together the AI or agent stack that you want. And we also want you to be able to just get further faster. So you can actually get something out and deployed quickly and then have time to iterate on it rather than worrying about making a ton of tech stack decisions before you even know what you're actually building. So this is what we're going to do. And then we're actually going to jump into the code and we will see how much we can get done in maybe, say 30 to 40 minutes. And then we'll have some time to kind of do some follow up and maybe answer a couple questions. So we're going to create a new master project. We'll create an agent that can tell us the weather. So we'll do kind of the simple example. We'll run some eval metrics for our agent. We'll talk about a workflow that can plan activities based on the weather. We'll also then create an agent that can answer questions about maybe some personal finance transactions in a Google spreadsheet. And then we'll deploy and test our agent in production. So we'll actually deploy it somewhere so it can be live on the internet. And if we can do that in a half hour, I'd call that a pretty rapid fire workshop. So let's go ahead and see if we can get started. So I'm just going to get started by running, I guess, while I'm doing this, if you can't see anything, feel free to either unmute and tell me or, yell in the chat and, Sam, feel free to, you know, interrupt me. But hopefully this is all visible. Maybe I can make it just a touch bigger. Okay, so we're gonna run npm create Mastra at latest, just to make sure we get the actual latest version. And it's gonna ask me to name it. So I'm gonna say Feb 13 workshop. And this is gonna go in and install all the dependencies for Mastra. And Mastra is built so it can be run standalone, meaning your agent and your workflows are all run behind an API and you can deploy that independently of any other application. This means you could build an agent that can interact with a mobile app, a desktop app, a website. It can also be used, and we do have people that use it within an actual front end website like a Next.js site as well. So it's meant to be used in either way. But in this case, we'll just show kind of the standalone version, kind of running on its own. We're going to just add the defaults because it'll give us some boilerplate code to look at and see something working right away. We do want our agents to have tools, so we'll add tools. I am going to just use OpenAI, although I kind of like Anthropic better, but we'll use OpenAI because that's the most common. I will skip putting in my key. And then we do want to add the example. So this is just the weather example we'll go through first, and we'll take a look at the code. So I'm going to go into this, and I'm just going to copy over my environment variables, which has my OpenAI API key. But typically you would just need to drop that API key in. I will just drop it in here. So the first thing we can do is, rather than looking at the code first, let's actually run the development environment. So Mastra comes with a dev server that allows you to see your agents and your workflows immediately and kind of iterate and test them. So we're going to run npm run dev, and this is going to spin up and run the Mastra dev command. So you can see it starts, it has an open API spec, so we can actually interact with the APIs that it gives us. And we can also then just open the playground. So I will open that up, and hopefully you all can see my screen. We can see the playground. So there's this weather agent. Let's actually chat with it and see what it can do. So let's just ask it what it can do here. And you can see over here on the right, it tells you the instructions that this agent has. It tells you it's using GPT 4.0, and it has a tool called Get Weather. Let's just ask it the weather. So I'm from Sioux Falls, so let's say, what is the weather in Sioux Falls? And it says the current weather is -19 Celsius, so that's pretty cold. And because I'm in San Francisco, let's just check what the weather is in San Francisco right now. much better. And, this is kind of nice, but I actually would want this in Fahrenheit because I don't actually know what this feels like. I have a general idea. Let's actually update that and get that working. So let's see how the code actually works. I'm going to go here and I'm using, so I'm going to be using a editor called Windsurf. Some of you may be using an editor called Cursor. If you haven't used one of those tools, I'm going to be kind of showing you how the way I develop has changed a lot over the last probably 18 months, definitely the last 12 months. So I will be showing you kind of how I build things. And I would encourage you, if you haven't tried some of these tools, just to spend some time with them because it does kind of change how you write code. If you've been doing it for a long time and you are looking to maybe move a little bit faster. So let's take a look at what comes out of the box when we created this project. The most important thing is there's this source directory. We have agents, we have tools, we have workflows, and then we have this index file. You can see that we just create or instantiate this Mastra class. We pass in a workflow, we pass in an agent, and we basically say that we want a logger attached to it. So because this is hopefully pretty self-explanatory, we know that there's probably our agent probably lives in here. The tools the agent uses lives in here, and the workflow, which we didn't look at yet, but we will soon, lives here. So let's go to our agent. You can see here those instructions we saw. I'm going to say always respond in using Fahrenheit, convert Celsius to Fahrenheit if necessary. So I'm going to save that and then we'll go back and see how, if it actually listened to that. But we can look at the tool as well. So there's a lot going on here, but this is really the kind of the base of it. We actually create a tool. We're calling it weather tool. And it's going to have an output schema of the temperature, humidity, all this information. And it just calls this get weather function, which we have written code down here. It's actually calling out to this API. It's fetching the current response based on the location. And then it is going to, basically get that information, return it in this format. And the really cool thing about this is now I have basically been able to wire up OpenAI's, in this case, let's see what we're using, OpenAI's GPT-4o to be able to decide that it wants to run code that's living on my system. So that's pretty interesting because now I can change this code, give my weather agent different tools, and it can then execute that code and then make decisions. So if we think about like what's happening when I actually do this, if we go back here, oh, I do need to run dev again. Did I stop that? And you can see it says always respond in Fahrenheit. We'll see if it listens, but let's just talk about what's all happening behind the scenes. So I ask what the weather is in Sioux Falls. Hopefully it does it in Fahrenheit this time. Still in the negative. So yeah, pretty cold. I am happy I'm not there today. But let's talk about what actually happened, and we can actually dig into it a little bit. But it sends the request to, OpenAI, and then GPT-4o has decided I need to get the weather, so I have these available tools. So I'm going to call this tool. It comes back to my machine, runs the code on my machine, passes the result back to GPT-4o to then analyze that and then kind of synthesize the data and return this response. So there's actually a few hops that are happening. So if we look at tracing, we can see that a couple things are happening here. So let's just say we're streaming text. There's a system prompt that says you're a helpful weather assistant. I asked, what is the weather in Sioux Falls? It did this tool call. So it called this weather tool, and there's the actual data that was returned. So this was, this tool call was run on my machine. Then it, passes it back. And there's some information here. And then last, this one should actually have the result, which is right there. So there's the actual response. So you can kind of see, we can dig into all the steps that happen in just that one chat message that I sent it, right? But let's go ahead and try to extend this a little bit. And let's give it another tool. Maybe before we do, I will show you really quickly what a workflow looks like. So we have this workflow here that was pre-created. Basically, it'll fetch the weather, and then it'll plan activities based on the weather. So we know it's pretty cold in Sioux Falls, but let's see what activities it plans. And you can see it's actually streaming to my terminal here. So as it's kind of thinking through, it's saying, if I want to do outdoor activity, dress warmly due to extremely cold temperatures. Yeah, you don't say. But it'll basically, like, 4 different days tell me the weather, upcoming weather, possible activities, snowman building at McKinnon Park. Sounds a little cold for that, but maybe. The library maybe is a little bit more appropriate. I do have a 3-year-old who likes the library. So as you can see, it basically comes up with a response. It then eventually will output it all once it's done. And if we look at what's actually happening in that workflow, in this case, we just created a new agent that we use just for this workflow, but we define steps. So this is that fetch weather step, and it's running this code here. And so this is very similar to the tool call code. We just duplicate it because, it's a simple and very verbose example, so you can learn from it. And then we have this plan activities step. And that plan activity step does some other things and kind of prompts the agent. So it calls agent.stream and it passes in this prompt, says based on the following weather forecast for, in this case, it would say Sioux Falls, suggests some activities. But this is where all the magic really happens. So we defined those steps above and we create a workflow. It says the first step is fetch weather, then we plan activities. So if you think about that in your head, if you say that out loud, you're going to come up in your head with something that looks like this. First, we fetch weather, then we plan activities. In some cases, you might want to execute things multiple steps at the same time or have dependencies, add conditionals. You can build a pretty complex workflow. And then, of course, you can kind of see traces for how those steps happen, as we kind of showed in the agent section. So that's workflows. We won't spend too much time on that, but you can think about, you can build a little bit more deterministic flow. And then there's some parts of this that actually call out to LLMs. In this case, getting the weather, it does like do some processing. It goes to the API, I guess, and fetching weather, and then the planning activities calls out to the LLM to take that weather and then synthesize like some kind of plan for you. So you can see it's kind of multi-step and uses an LLM call at certain steps of it. Whereas an agent gets to kind of choose based on the tools it has what is used. Technically, like both of these are agentic, right? It just depends on what you need, on which you use. And often it's a combination of both. You may have agents that can call workflows. You may have workflows that call agents. So it's kind of you have a lot of puzzle pieces you can put together as you need. And we do have a tools section that allows us to execute just in any individual tool. And I'll show that here in a second. Let's go ahead and just add a new agent. So we have this weather agent, and we have this weather tool, but I actually want to create a new tool. I have, if I can pull in here, I have this spreadsheet with fake transaction data. Think of this as like if I were to pull my credit card statement or my bank account statement, and I want to be able to then ask questions about this. So the first thing I need to do is I'm just going to make this public. I think I already did that. So I'm going to just make this public, and I'll just make it a CSV. Mainly so I don't have to deal with the authentication parts, but just like any other, if you've ever interacted with an API, we could go through the auth steps and make sure that, my code could actually correctly authenticate to this, so I wouldn't have to make it public, but making it public just speeds things up. Let's go ahead and if you haven't done this before, this might seem a little weird, but I'm just going to ask Cascade here to write this code for me, and then we'll talk about what it's writing and how it does. I need a new tool called get transactions that will go to a Google Sheet URL and return CSV data. Please use the create tool example in tools. And then I'm going to say also add the tool to a new agent similar to the example in agents index. Okay, so what I'm telling it is I'm basically telling it I want it to write a tool, and I do need to provide the URL. Use the following Google Sheets URL to fetch the data. Okay, we'll see how it does. It might not get it right, but I bet it gets it pretty close. So it's going to look at my current code. It's going to then, tell me what it's doing. It's looking at the tools file. It's looking at the agents file. It's then going to create a new get transactions tool and then add it to the agent, or add it to a new agent. So first it's editing the tools index file. We should see some code here coming in pretty quickly. And you can see it's writing some code. And this is, it wrote a tool called transactions tool, get transactions, get transaction data from Google Sheets. And this is giving me the output scheme as an array, which is actually, that's probably okay. If we look at what the actual get transactions does, it fetches from this URL. This is probably going to work, but I just want it simple, a little simpler. So I'm going to say, can we make the tool only return the text, the CSV text? Don't do any parsing, just so we make sure it works. So this will update this. Right now it's parsing the CSV. It's a small enough data set that I really don't care about the parsing for this example. But, I would definitely want to test this and make sure it gets it in the right format. Having structured data is typically better. So normally I wouldn't do this, but we'll just keep the example a little simpler, so it's a little easier to understand. And then it's going to update the agent instructions. So you can see there's a transactions agent. It's using this transactions tool, which it's getting from here. And we're just going to accept everything. And I don't know if this is going to work. We do need to come in here and add our agent. So we're going to add our transactions agent to our import and to our master class. And now if all goes well, we should be able to come back to here. We see we have a transactions agent. Let's chat with it. And let's just say, how much did I spend at the Apple Store? I spent $1,299. Must have got something nice. Let's see if that's true. Apple Store, $1,299. So if we were to look at, oops, lost my spot here. If we were to look at the trace, we could see that it's going to make this tool call to this transactions tool, and it's returning all of the CSV in a string format back to the LLM, which is then kind of processing that, looking up and seeing that, here there's a transaction for the Apple Store in this amount. Could also come back and ask it, how much did I spend in my PayPal account? And this should be able to take, if we look here, there's multiple PayPal account payments. So hopefully it'll do some math and get this right. And there you go. You can see it takes both those transactions, it adds it up, and it returns the data. So of course I could, update this transaction list, add more transactions. Google Sheets does cache this data. So if you do test this, just know that it might not show up right away. You might have to unpublish it and publish it as well to get it to actually load the data in because it is cached for a while. So it might not be immediate, but you get the idea. I'm actually just an LLM is going to this, running code on my system, which pulls data from this spreadsheet, and I can ask questions about that data. So you can imagine how this could be useful for all different types of data, whether that's local files on my system, whether that's files behind some API somewhere, but you could wire up agents to do all kinds of things. The last thing I want to do though is I don't want two different agents. I want to actually combine these things. So let's go ahead and say combine the weather agent and transactions agent into a single agent with two tools. Because typically I would want just a personal assistant that could do multiple things. So rather than having to know if I want to call and ask for the weather or know if I want to ask for transactions, I'd like to just have an assistant that I could ask either thing and it would just make the decision. I don't really like it called combined agent. So we'll update that. Let's call it assistant. So this should update it. It'll call it assistant. And then we'll give it one quick test. We'll actually add so we got about maybe 15 minutes. So we'll see what we can get done. But in the next 15 minutes, hopefully we can add an eval. We'll talk a little bit about evals just real briefly. And then we'll try to get this thing deployed and actually out in production here. Let's see, did it actually work? So we have an assistant. You have two main functions. You can do weather, you can do transactions. It tells us about the tools. It adds the two tools there. The one thing I would just encourage you, if you are using something like this, make sure you're actually reviewing. We're not really reviewing this code very quickly, right? We're moving pretty fast. I would highly encourage you to make sure you know what the code's doing because it's not always right and it can lead you astray. And it continues to get better and it continues to impress me every day. But just don't completely trust it. So the agent we pass in is the assistant. And then, of course, I think our assistant does have our two tools. So great. Let's actually run this thing. And we're going to need to go back. We have our assistant. Let's just see if it can tell me the weather. What is the weather in Los Angeles? All right. And how much did I spend at Amazon? Okay. So you can see it can now decide. And if I were to look at these traces, it's, in some cases it would use the weather tool. Some cases it would use the transactions tool, but it was returning the right results. So that's good. Let's go ahead and add one eval just to show how it works. So I'm going to go to the Mastra docs because all this stuff is kind of in the Mastra docs. So I'm going to go down to evals. They sound like a brand new concept, but if you've ever written software tests, it shouldn't be that new. That's really what an eval is it's kind of like a non-deterministic software test. You basically want to measure is something working correctly, and you might not get just a yes or no like you do in tests. Sometimes it's almost like a score, and so you're measuring that score over time. We have a whole bunch of different eval metrics. Some of them are more useful than others depending on what you're trying to do. My recommendation is typically you should just try to write a custom metric. In our case, I would want, to make sure I would write a metric to make sure it always returned weather in Fahrenheit, right? If that was part of my business goals of building this assistant, or make sure that it would kind of validate or check the math on my transactions if I were to ask it something more complicated, because sometimes it can get hung up on math. So those are the type of metrics I would probably want to build. But that you can also use some of these off-the-shelf metrics to give you some data right away so you can get that kind of instant feedback. The first thing I need to do is run npm install at mastra/evals. And that's just going to install our evals package. And we can go to our agent and we should be able to add this tone consistency metric, which we'll talk about what that is in a second. But we'll look at some of these different supported evals. So we have a whole bunch of evals on accuracy and reliability, on how well it can understand context, and then on output quality. So if we look at, tone consistency, it's saying evaluates the emotional tone and sentiment consistency. So this is like a NLP or natural language processing metric. You can also have some metrics that, some metrics that actually use another LLM to actually do the judging. So it's often called LLM as a judge, something like answer relevancy. So in this case, we can use, in this example, we would be using 4.0 mini to run this metric and then decide how good of a result it was. So you're actually using an LLM to judge the output of another LLM, which is kind of interesting, but also can be, much more scalable than asking a human to do that evaluation. Ultimately, you need probably a mix of both, but in the cases where, humans are very expensive to spend time doing these things and judging results, having an LLM act as a judge is kind of useful. So we're just going to use this tone consistency metric so you can see how it works. But you could, of course, just copy those code samples and run any of those metrics pretty easily. npm run dev. So we'll go back in here. We'll run one more example. What is the weather in, let's do Sacramento. Sacramento. How do I spell Sacramento? Is that right, Sam? I don't know. You live there sometime.
Yeah.
Not anymore. Not right now, but all right, we got it. Way warmer than Sioux Falls. So let's take a look at the evals, and you can see we now have this tone consistency metric, and it scored a 0.95 out of 1. So that's not too bad. But, I would encourage you to read through what the eval metrics do so you can actually see if they're useful for what you're trying to do. And a lot of this stuff accumulates over time. So this initial like one eval isn't that important, but you might want to track it over time and just check in on some of these off-the-shelf evals to see if you change your system prompt and something degrades or goes down. I think that's where it could become even more useful. The one other thing is I will show in tools. We may want to just test in an individual tool before we give it to the agent. In our case, we were doing pretty simple tools, so we didn't need to. But if I wanted to test the get transactions tool, I don't have to fill out any input because I didn't, it's just returning the same thing every time. But you can imagine if I did have filters for date ranges or something, it would show up here and then I would get the output. So if we go to weather, you'll see that it asks me to input the location. And then it will just run that individual tool and return that data. Okay, so the last thing we'll do, and see if we can get this done in about 5 minutes, is to deploy this thing. So I'm going to do git init, and I'm going to deploy this thing to Git. So I'm going to add this, commit, workshop, and we'll go to GitHub, and we'll just create a new repo really quickly. Now I'll make it public so we can share it out if you want to try this on your own. And this should push up the code. And I'll drop this in the chat in case you do want to, take a look at it. And let's go ahead and in this part, we haven't actually announced this really publicly yet, but we're going to go to Mastra Cloud. So it does exist. It will be announced, pretty soon. And we're going to look at I'm going to grab this Feb 13 workshop repo that I just created. We need to open AI API key. So I need to add my environment variables. This is basically just going to spin up and run all of my agents and workflows over, basically provide me an API that I can use so I could wire it up to any other, front end application I wanted, or, mobile app or whatever. So I do need to drop in this API key. So give me just a second to do that. And then I will deploy the project. And what this is doing is it's going to take all my code, it's going to build it, and then it's going to essentially run those APIs. So I have a scalable method, a scalable way to run my agent, or especially with if you've built applications using some of the other front end tools out there, you might have run into like function timeouts if you've been using serverless functions. So we kind of handle all of that, so you don't have to necessarily worry about it. Well, while we let uh, this thing kind of go, I'll just pull it over here so I can watch it. Let's go ahead and kind of go through some of the final slides, and then we'll come back and we'll show this thing running here in production. All right, so we did all this, and we'll of course do this last step here in a minute. But let's talk about things we didn't do. We didn't have time to get to. We didn't talk about memory. Memory is the ability for your agent to remember, conversations. So right now, every time we chatted with our agent, it was just like a new message that it didn't know, have any history of what we asked it previously. In Mastra, turning on memory is very easy. You just, do a flip a few switches basically, and it just works. We didn't really talk about human in the loop workflows, which would be the fact of maybe I would want, a validation step in that workflow when I planned activities to ask me, do I want, indoor or outdoor activities, or, do I like the direction that it's going? And so maybe there'd be some kind of feedback mechanism. Tools are very important. You saw that we had to manually build the tools ourselves. There are some kind of tool providers that you can use that will allow you to provide your agents more tools way more rapidly. MCP is called a Model Context Protocol. That's an open source kind of movement around building agent tools. There are other tool companies. One example is Composio that kind of try to help solve the tool problem. So there's a whole bunch of different ways you can try to solve tools besides just writing tools yourself. We didn't show anything about RAG, which is retrieval augmented generation. This is important if you have a lot of data that you want to search through. The LLM can only handle so much in its context at one time. So the context window is basically the amount of, think about like working memory, a human has. That's kind of similar in the context of an LLM. It only has so much that it can keep in its head at one time. So RAG allows you to kind of do a search and then insert data into that so you can better look up information and then use that in your results. And then I mentioned briefly custom eval metrics, which would be writing your own eval metric that kind of aligns with what you're trying to get out of your agent. So those would be things. The nice thing is in the master docs, those are pretty much all top level items where you can dig in and start to learn more. I have some examples, and I will share these slides in a follow-up email after this, where these are just some examples we published. If you go to the blog post, there's links to the actual source and the demos. So you can see some slightly more complicated Mastra examples. And what we showed is just deploying the backend. And I'm going to actually check and see if it's done. And it looks like it is. So great. We'll pull that in just a second. But if we wanted to deploy a front end to connect to our backend, Assistant UI is basically a way to really spin up kind of chat assistants really quickly. So we have an example using that. You could grab that code, just swap out the Mastra API URL and point it at your agent, and you could have a fully working front end deployed to Netlify, to Vercel, to any other front end hosting platform pretty quickly with just a a few lines of one line of code in an env file, basically. So let's go ahead and take a look at our deployed application. So we have our February 13 workshop. I don't actually, let's take a look here. And you can see we have logs that it was built. And I'm going to actually go back and go to this one here. So we have this URL that it gives you. And this URL should actually return an API.json file. Let's see if it's running here. It's still loading. Okay. And then this gives me all the available endpoints. And the nice thing is I can use something like curl then or postman. And this is just an example that I had used earlier, but how much did I spend at Amazon? So I can run this and it's actually going to go out to my agent that's sitting out on Mastra Cloud. It's going to pass in a message, how much did I spend? And then it's going to return the text saying you spent a total of this. So it's basically doing all of this thing, all the things we showed in dev, but it's available, in a production ready, scalable version that I could wire up to any application. Okay, we went through a lot. It's 9:45. That's pretty good. How's everyone feeling? Do we have any questions? Maybe now's a good time for some questions. I will stop sharing my screen. Okay, so Sam, you've been answering some, it looks like, but any other questions that we want to talk through now?
It seems like the most interesting thing that people and a couple people are interested about sort of how do we manage agent memory? So, Shane, maybe you can take a whack at that.
Yes, so we kind of have some systems that are built in. Let me go to the memory docs and kind of walk through some parts of it. But when you're thinking about memory, you have like what's considered like a short-term memory, which is maybe a thread of the last X number of messages. And then you have the idea of like longer term memory, which you want to be able to go and retrieve when someone asks for it. And so we have kind of some memory management. There was a paper called MemGPT. We based a lot of what our memory does on that, with we'd like to say some improvements on that to make it faster, but it's based pretty heavily on the MemGPT paper. And let me share my screen so we can just kind of take a look at the docs here. So in memory, you have this idea of threads and resources. So in your code, if you do call agent.stream, which is a way to stream results back from an agent, you can pass in a thread ID. You could pass in a resource ID, which is typically a user ID from your application. And now memory will just be managed for you. Now, there are some things you might want to do. So you may want to kind of pass in some memory options. Like you can pass in how many of the last messages you should use. You can do some semantic search. So you can add semantic recall. So you can say, I want what's top K, which is like the top matching results. In this case, the best 10 results. And then the two messages before and after each of that result. So you can pass in the context. So then in this case, we could pass in what types of memory or how much memory we want to pass into the conversation. And then you can also use some different vector databases. As I mentioned before, you're not kind of tied to one vector DB. You could use PG vector in this case. You could decide which embedding model you want to use when you're embedding memories. So there's a whole bunch of different configuration options there. And the idea is out of the box, you can just turn it on and it just kind of starts working. But very likely, as you get more sophisticated, you're going to need to be able to kind of turn the dials. And so all the dials are there for you to be able to turn. That's a good question, though. Any other questions that we were running into or getting asked, Sam? I see
Yeah, there,
Abby's here, like tackling some questions as well. So
there's
he,
one that there's one that might you might want to sort of call out. Rodrigo's asking how you structure a next app that uses Mastra. He's asking if he should sort of deploy them separately or together or how, different repos, same repo, how should that work?
yeah. So that's a really good question, and it really does depend on your goals. If you are looking and you know that you're only ever going to have a next app and it's never going to extend beyond that, and your use case is, say, let's say relatively straightforward, then you can actually add master directly to your next app. There is some challenges with maybe some TypeScript things that you need to make sure. You need to check your TS config file, but you can basically run the Mastra init command on your Next.js app. We do have a guide that's coming out soon, so we'll have a little more straightforward instructions for that. But we do have a lot of people that do that, and that's nice because you can keep all your code in one place. You can deploy it, to Vercel, Netlify, wherever you're deploying your next app, and it should all just work. And then you don't have to worry about two code bases. As your agents and workflows get more complex, I think there is a lot of value gained from having a separate API that's run, as its own application. And then we do have a client, basically just a JavaScript or TypeScript client that you can then just use in your next app to reach out to your Master Agent API. So it does depend a little bit. My preference is separate because I like separation of concerns, but a lot of people would rather just have one application. And if that's all you've ever or all you're planning on doing, then running it inside your next app can sometimes make sense.
And then now Huey's asking if we have any example of a multi-agent.
Yeah. So in our examples, we do have a hierarchical multi-agent system. So in this example I guess this one's not a workflow. So this one is more multiple agents that can call each other as tools. We do have in workflows, we do have calling an agent. And so you could think of, you can build a system where you can call multiple agents in a single workflow. So we have a couple different examples here. Here's a multi-agent workflow, I guess, as well. So in this case, we define a workflow that in this case calls a copywriter and then an editor, and they're two separate agents, but we've kind of defined a workflow that calls that. There's a whole bunch of different patterns you can follow when building multi-agent systems. The most common ones that we've seen is either a more general workflow that calls into certain agents in certain steps. And then maybe you could always, think about ways that you might want to uh, have those agents talk to each other. The other one is using agents as a tool call into other agents. So you basically have one agent that's maybe like a supervisor that has tools that can call into these other agents to get certain types of information. And so if you think about like you might have an editor that is responsible for the entire blog publishing process. You might have someone that's responsible for generating the ideas and the research. You might have an agent that's responsible for actually writing the copy, and then you have an agent that's responsible for reviewing and like making changes to that copy. But you have one that's like the supervisor or manager that calls out to the different tools, and maybe you define the order of that, or you just let them decide, or let the LLM decide. So a couple examples in here of doing that.
At the
That's a
end
good
of the
question.
day, hi, this is Avi. At the end of the day, this is all JavaScript, right? And I think a lot of times the AI frameworks and libraries seem very intimidating. Maybe you're not very comfortable with Python or you're new in the space, but our goal in design with Mastra is it is just JavaScript, right? It should be approachable. Anything that you can think of in JavaScript, you probably can do. There's not like any limitation there. So I'm excited to see what everyone builds.
Yeah. I dropped a link in the chat that has a nice diagram for multi-agent. This is something that we share a lot internally. Uh, and and so what this kind of illustrates, right, is that there's often like we've been talking about in the chat. So there's multiple primitives and you can rearrange them in interesting ways. There's often multiple ways to solve the same problem, and you are going to be the one that needs to sort of figure out like maybe test two or three of them out and see which one of them works better. Um, Keep in mind, right, when typically when we're writing software, we get used to sort of the software is predictable and it always does the same thing. And agents are not always that way. And so, there, it may be that like one arrangement here works better for you. Um, Something that we've seen is that often a person can get working on an AI application or an AI feature can get to a prototype, maybe in a week or a couple of weeks. But then, then they spend the next month or 2 months kind of productionizing it, which means getting it reliable enough that they feel comfortable shipping it to customers. And yeah, I think that's like kind of the pattern, right? First, just get something working, get it to work, and then over time, you're going to get it right as you improve the quality. And that's through evals. That's through the feedback loop that you have. Um, and that's powerful because, in the beginning, you can just focus on, hey, I'm gonna, get this to work, but then over time you're sort of using the scientific method to test your application and just try different configurations. And you're using your understanding of the possibility in the idea space, to kind of traverse and iterate towards the most predictable and the most reliable solution, right? And that might be tuning your prompt, that might be multi-agent configuration, that might be going from how you structure it and how you're doing tool calls to workflows. But the fun thing is, and this is one thing that we've done with Mastra, right? We have intentionally baked in all the primitives that you'll need, so you can just kind of switch between the different building blocks within the framework.
Yeah, great point, Sam. I did see one other question asked, TypeScript versus Python in writing and building agents. So this is I would say it depends on your background and what you're more comfortable with. That's kind of like saying, should you build, in PHP or Ruby on Rails, back in the day, or, like there's different languages, right? For what, if you've built websites before on different web backends and different frameworks that you might use. I think there's Python was the most popular getting started because a lot of this stuff evolved from the machine learning communities, like machine learning engineers, which were very heavily built on, research and kind of data analysis, which is why Python was the initial use case for, and that's why there's way more Python AI frameworks and agent frameworks out there right now. We're seeing more and more JavaScript usage and JavaScript frameworks emerge. And I think that's because, Python's really useful for many things, and that's kind of the first language people learn. But often when you get to the point where you're building things, a lot of, especially the application world, is built on, front-end frameworks, JavaScript frameworks, things like that. So you see a lot of TypeScript and a lot of JavaScript. And so I think you're going to see more and more applications and agents and AI tools being built specifically for the JavaScript and TypeScript communities. So I think it will shift more to being a little more 50-50 over time, even if Python is a little bit more popular right now. We're
Yeah.
currently in Y Combinator, and there's 100 plus AI agent companies, I would say, very close to that many in our batch. And most, they're probably 2/3 are maybe using Python, but more and more are either considering or have started using TypeScript. So I think it's shifting.
Um,
Okay.
so uh, and then and TypeScript is now that most of AI engineering is just building on top of OpenAI and Claude Anthropic, it's TypeScript just becomes more and more powerful. Um, a lot of
Brad,
folks just prefer to have everything in one language.
yeah, exactly. Yeah, your front end application can be built in the same as your AI application. So Brad has a question. How might you mutate workflows and agents at runtime? I'm baking fewer and fewer prompts into my production code, so making them configurable. So, stay tuned on, we might have some solutions for that in the very near future, Brad. But in general, you can, yeah, because it's just a class, you can kind of pass around agents and update agents as needed. So you could load something from the database, you know, change the instructions of the agent and then execute something to that, you know, execute a stream call or a generate call right to that agent. So it is all possible. You would just kind of write your application code where you fetch from the database and then either dynamically build the agent or dynamically update a part of the agent. But yeah, it should all be possible. But yes, we do have something coming where maybe you don't have to do all that yourself and you could just use something within Mastra for that. Because yes, it's a very common use case actually of having, how do you iterate on prompts fast, quickly? How do you measure if the changes you're making actually are making things better? So you have some level of confidence, right? You're not, what people often refer to as you're not just shipping on vibes. But yes. Okay, well, I think we're at time. So feel free if you have, there's some, I'll send out the slides. Feel free to join the Discord if you do have more questions and you want to chat through some things, or of course, just send me an email, find me on social. Appreciate you all joining, and yeah, we'll see you all around.
Thanks for coming. It's been an absolute pleasure.
See y'all.